Welcome back. We started solving this question in the previous video and we considered the first part. In this video, we are going to consider the second part of the question. So let's do that. The second part of the question says that a market is to be built to serve the three towns. It is to be located such that traders from town N and town M will always travel equal distance to access the market, while traders from town P will travel exactly 10 kilometers to reach the market. Using a ruler and a pair of compasses only, find by construction the possible locations of the market. In the previous video, we saw that there are three towns, town M, town N, and town P. And using the distances between the three towns, we were able to construct the triangle MNP. For the second part of the question, we are being told that a market is to be built to serve the three towns. We know that in building a market, one of the key things you have to consider is the location. In order to get the location, we have been given two conditions. The first condition is that the market should be located such that traders from town M and town N will always travel equal distance to access it. And the second condition is that traders from town P will travel exactly 10 kilometers. So the location of the market should be such that it satisfies both conditions. We are going to consider these two conditions in this video. Let's consider the first condition. The first condition is traders from town N and town M will always travel equal distance to access the market. This is the triangle we constructed in the previous video, triangle MNP, which shows the distances between the three towns. In locating the market, we have been told that the first condition is that the market should be such that traders from town N and town M will always travel equal distances to access it. This means that the distance between the market and town M should be the same as the distance between the market and town N, meaning that the market should be equidistant from town M and town N. From this, we can say that the position of the market will fall on the locus of points equidistant from town M and town N. So using this condition, the market will be on the locus of points equidistant from town M and town N. From the previous videos, we have learned that the locus of points equidistant from two fixed points is the perpendicular bisector of the line joining the two fixed points. So the locus of points equidistant from town M and town N will be the perpendicular bisector of the line joining point M to point N. So to get the locus of points equidistant from town M and town N, we will have to bisect the line MN. To do that, we will take the compass and put the needle on point M. You can start with point M or point N, it doesn't matter. Here I'm starting with point M, so I'll put the needle of the compass on point M. Then after that, I'll open to more than half of the line MN. Then after that, I'll turn the compass to this side and construct an arc. Then with the same radius, I'll move the compass to this side and construct another arc. After doing this, I'll move the needle of the compass to point N. Then with the same radius, I will turn it and construct an arc to intersect the first arc that I constructed. Then I'll move it to this side also and construct another arc to intersect the first arc that I've constructed. I'm going to clean this side of the arc. Then when I come here, I'll clean this side also. We can see that the two arcs intersect at this point and this point. To get the perpendicular bisector of the line MN, which will give us the locus of points equidistant from point M and point N, we will draw a straight line to join the points of intersection of the two arcs, just as we have done here. The location of the market can be any point on this line, since any point on this line will be equidistant from point M and point N. So by considering the first condition, we have a very wide range of possible locations of the market. Let's consider the second condition so that we can reduce the range. The second condition says that traders from town P will travel exactly 10 kilometers to reach the market. So this means that the distance between the market and point P should be exactly 10 kilometers. Points that are 10 kilometers from point P will give us the locus of points 10 kilometers from point P. We have learned from the previous videos that the locus of points equidistant from a fixed point is a circle with the fixed point as the center. So here, the locus of points 10 kilometers from point P will be a circle with point P as the center and a radius of 10 kilometers. But we know that in our construction, the dimensions we are using are in centimeters. So we will have to convert the 10 kilometers to centimeters. Once again, we are going to use the scale given to us. The scale given to us in the question is 1 centimeter is to 2 kilometers. This means that every 1 centimeter is equal to 2 kilometers. It also means that every 2 kilometers is equal to 1 centimeter. So using this scale, we are going to convert 10 kilometers to centimeters. If 2 kilometers is giving us 1 centimeter, then it means that 10 kilometers will give us 5 centimeters. So here, in order to locate the market, we will have to construct the locus of points 5 centimeters from point P. We have seen that this will be a circle with point P as the center and a radius of 5 centimeters. So first, we will pick the ruler and we measure 5 centimeters using the compass. So I'll put the needle of the compass on point 0, then I'll measure 5 centimeters, which will be 50 millimeters on my ruler. After that, I'll move the needle of the compass to point P. I'm going to take the ruler off so that we can construct the circle. The needle of the compass is on point P, so I'll turn the compass and construct the circle. This circle will give us the locus of points 5 centimeters from point P. This means that when we pick any point on the circle, the distance between that point and point P will be 5 centimeters or 10 kilometers if we are considering the distance in kilometers. We can see from what we have constructed here that when we consider the first condition, we had the locus of points equidistant from point M and point N to be this line. And when we consider the second condition, we are having the locus of points 5 centimeters from point P to be this circle. The circle and the perpendicular bisector intersect at this point. When we extend the perpendicular bisector, just as I've done here, we can see that the first locus, which is the bisector of the line MN, and the second locus, which is the circle, intersect at this point and this point. In the next video, we are going to use what we have constructed here to answer the 3 questions given to us. So see you in the next video and let's continue with the solution. Bye-bye.